So this workshop is around the wide topic of continuous integration for what concerns Kamailio. And I hope I can see the three main topics that are going to involve each one of you, which is the automation of the builds, the testing, and the deployment. So probably what I'm going to describe is not going to apply one-to-one for everybody. I hope we can trigger some discussions, can provide feedback, and it could be a starting point for further discussions. So I'm working around VoIP for some time now. Somehow, for some reason, I end up working on topic that can be defined as DevOps. So a little bit in the middle between development and interacting with ops and infrastructure. I'm currently working mainly with for the Libon project, the Orange Libon project. So for this workshop, I prepared something like some code that you can use right now if you want to just to be hands-on during the conversation. So if you want to just to clone that small GitHub project, it's going to have two main parts. One is building RTPengine inside Docker, and the other is simulating an entire infrastructure entirely with Docker containers, testing a new module that it's just brand new for doing asynchronous HTTP requests from Kamailio. So it's also an opportunity to talk about that. So if you go there, the README should be sufficient to allow you to prepare the base images, and we'll see later what this means. So very quickly, I think each one of you knows what CI means, but in a few words, it's just the need to synchronize different developers working on the same code base. This happens already publicly in the Kamailio community with Travis CI, so each commit can trigger an entire test suite. But what happens is that typically teams in different projects need to build their own copies, not necessarily public, and build their own packages or RPMs that are not available from the main project. Of course, the main idea is that you save time because every time you have a change, you build and test the change, and basically you have a reduced requirement for infrastructure. And in particular, since the releases are doing more frequently with small changes, they are less risky to push into production. The typical core of the CI infrastructure is the so-called CI server or CI tool. The most common are Jenkins and Travis CI. There are others like Bamboo, but these are the most common, and they are used typically for doing the three phases, so the build, the testing, and the deployment. Of course, they interact with natively with tools like Git or private or public repos for packages or even Docker registries. And Jenkins is the typical one used inside private projects or in general inside companies. Travis CI is more oriented to open source projects. So for the build automation, we can imagine a very simplified architecture where Jenkins is the main CI tool orchestrating the builds, and developers just work on their machines. They push on Git when they're finished, and then they can trigger specific jobs. So the jobs inside a CI tool is just a sort of scheduled or prepared cron with a set of instructions. The builds can be performed on a set of hosts delegated for the builds, and then the artifacts can be stored in a file system or pushed into a private or public repo. when we talk about buildings, is the typical scenarios that each developer has, of course, his own built-in machine with its configuration and virtual machines. The traditional way of working with Jenkins, for example, was to have Jenkins with a dedicated slave. So Jenkins is the master and there is a slave where all the builds are performed. But since there is a huge set of different configurations for distributions and also configurations inside the distributions and library configurations, you need a sort of explosion. You have an explosion in terms of combinations of the environments for the build machine. So you can imagine to dedicate containers to each building scenario. And to do this, there are the two common tools for Jenkins, for example, is a Docker plugin that allows you just to manage containers from Jenkins natively. Or, for example, if you have a Mesos managed infrastructure for containers, Jenkins can interact with Mesos to provision containers on demand. Of course, when you build, then you have the artifacts. The famous and publicly available are the Debian packages, but also depending on your infrastructure, you may need RPMs or simply tarballs, and in some cases, Docker images. The repos can be private or public, of course, and but one thing that is important is how you get from the original Git commit into production. So the ideal scenario is where you build once, you test it throughout all the stages and all the environments, and you release basically what you built just once, because every time you rebuild, there is some risk linked to the building task itself. So the consequence is that you also need some sort of unique versioning when you do the builds. Otherwise, you have ambiguity on what you are actually pushing into production. This calls for a problem, which is how clean is your build environment? Because if you start from sharing the same infrastructure among different apps or even different versions of the apps, which may have slightly different requirements in terms of libraries or distributions, then you risk to have a building environment which is polluted, is not as clean as you want, and you may have side effects that you really don't want. So you may think about cleaning up the environment every time you need to use it, or you can even imagine to set up a new environment every time from scratch, and have the so-called non-event releases, where basically you build something and then that one that you build, it goes through the pipeline for testing and eventually ends up on production because the tests were all successful. For this point of view, I think the huge opportunity we are facing in the last, I don't know if years or months, but anyway, I think it's Docker. And so very quickly, I think most of you know Docker already, but the main thing is it's a very lightweight way of virtualizing environments. So basically, you don't have all the overhead of a virtual machine. You don't have hypervisors. But the applications running inside the containers have the illusion of having the entire machine for themselves. So you move from having a few VMs dedicated to the builds into a sort of infrastructure that is just supposed to host the containers. And you ensure that the builds are clean and the environments are clean because every time they are rebuilt from scratch. And I'll try to see something, something in a practical Git that could be practical and interesting for you right now. So very quickly, from the point of view of moving from a virtualized system to a Docker approach, you don't have the overhead of the hypervisor, and you basically run in a sort of isolated user space environment all the applications. The price to pay with Docker is that the kernel that you have to use must be the one in the host machine. So this could make you suspicious about things like building rtpengine, and we'll see the caveats there. So very quickly, what we need to build Kamailio is just a clean image where we install the pre-requirements. After we have the image, the so-called base image, we can do all the builds on top of it with the source code that will vary depending on Git references, Git hashes, or even different distributions. And one thing that we need to keep in mind is that it's possible to reuse the same container once we've done a build for rebuilding. So we need to take care of stopping or even removing the containers when needed. So an example of a Dockerfile. So a Dockerfile is a recipe. It's just a text file that describes what the Docker image should contain. And this is a very simple example of preparing a Docker image for building Kamailio. So you can see you take a public generic CentOS 7, for example, image as the base. And then with a write-on-copy approach, you install the other requirements and then ensure that the YAM configuration is clean, just to keep the image size as small as possible. So this is basically this explanation. Once you have the build image, once you have the Dockerfile for the build image, building it is as simple as doing a docker build -t. Then you assign a name to the target image, and then you specify which Dockerfile should be used to build it. We'll see an example practically with rtpengine. A couple of things that I like to say about using containers for building. So you may be tempted to do a git checkout inside a container, which is perfectly understandable. What I try to do is always keep the Git configuration and possibly the source code outside of the image. And this can be done by accessing the source code from inside the container at runtime through what they call a volume. So a volume is basically a shared folder between the host and the container. Each time there is an instruction in a Dockerfile, in particular a run instruction, there is an additional layer to the file image, so to the file system. So basically, a way of keeping the size of the images small is limiting the number of instructions, and keeping, if possible, whatever changes at the end of the Dockerfile, so that you can use the cache system that Docker uses. And if a layer doesn't change, it reuses the same, it doesn't rebuild it, and speed it up the image preparation phase. Of course, as I mentioned, there is a risk of reusing containers when you don't want to. We had some examples of builds, or I don't remember if it was a build of a test, which result wasn't quite what we expected. And the reason was that Jenkins was asking Mesos for a container to do a build, and basically Mesos was providing a container already existing and used in other circumstances. So there was the illusion of using a clean environment. In fact, it was already polluted by previous builds. So the recommendation is to be careful and possibly have a one-off policy for the containers. Just use once, then destroy, so that the new one will be rebuilt from scratch. So once you have the base image, which in this case is, for example, gvac Kamailio async Debian. So gvac is just the user. The typical name is the user slash a name for the image and then colon a sort of tag, in this case, a Kamailio async for Debian. Then what I'm passing here is a volume for the source code. -v represents the volume. And then a volume for the scripts for the build. And it's generalized in that case. And the build can be as simple as this shell script where you just share the typical list of instructions for a build. And at the end, not in this case, but at the end, it's imaginable that if you trigger this with Jenkins, you will have a phase in which you take your Debian files or RPMs or tarbles, and you push them into the registry. So you can imagine that from a CI tool, you run the build job, which could be triggered by on demand or scheduled. You create a slave from scratch. So the slave will be a container. You do a git checkout and you do the build. At the end of the build, you store the artifacts. And you can, of course, you can imagine afterwards launching the tests and generating reports, notifications that can be via email or Slack or whatever system you use for these notifications. For rtpengine, so you have a big constraint, which is the fact that you are going to be the kernel module. But even if with Docker you have the constraint or only using the kernel provided by the host, it's also true that as long as you have the kernel headers available inside the build container, you will be able to build the version that you need and then to extract the artifacts, the kernel modules out. In this case as well, the base image for building rtpengine is very simple. It can be defined with this Dockerfile. And so here you consider, you just delegate one folder in the host to have the rtpengine code, source code. Then you build the base image, and then you run the build inside that base image. And this is actually what I wanted to try live, which I think could be also classified as dangerous demo in some sort of way.
Not when you do it.
Okay. So for rtpengine, let me zoom a little bit. So basically, we have the Dockerfile for the base image, which we can build as simply as docker build -t rtpengine. I think this is for CentOS. And then we can just pass the Dockerfile, which defaults anyway to a file named Dockerfile in the local directory. You don't need to specify it. And then with the final dot, I'm not sure how much it's visible, but anyway, with the final dot, you specify the so-called build context, which is all the, in this case, the current folder, all the files that are available in the current folder are visible by the Docker build process. In this case, so I just launched it. In this case, it was extremely quick, but there is a trick, and the reason is that Docker is reusing the caching system. So basically, since for each step of the Dockerfile, it's found already a layer with the same characteristics. It's just reloaded the cache and reused the image already existing. If you try this, it will take some time because it will actually build the image and store it for you. You may think about telling Docker explicitly to invalidate the cache. So in that case, it won't use the cache. Or you can change something. For example, if I change just the maintainer name, or if I add an environment variable, it will invalidate the cache of all the following commands, forcing Docker to rebuild the image. So in this case, we have the image available. It's available. I just built it 3 hours ago, so it's just reusing it. What we can do now is running the build of rtpengine with this image as the base. This one, so I'll just copy and paste this command. So in this case, I'm running a Docker run, specifying a name for the final container, and I'm providing 2 volumes. One is the one with the scripts, and the other is with the rtpengine source code. Then I provide an image name, which will be the base image on top of which to do the build. And then the last one is the command, which is just a build script, which I'll show you later. Now it's complaining because the container exists already, so I'm going to delete it. I'm going to delete the container, and then I'll run the build. So assuming it can connect, yes, it can. So in this case, it's running the build on top of the image that was already prepared, and the outcome of this will be a container with rtpengine built with the kernel module. And in this case, since the source directory is shared between the host and the container, the kernel module will be available directly in the host directory. I'll show you later the build script, which just, so this was successful, and the build script simply specifies a kernel version. So regardless of the kernel that we are running, well, there are some restrictions, but you can imagine that regardless of the kernel that we are running, we can specify the headers version, which then will be applied throughout the build process until we get into the build artifacts. You can see here that I'm using Git for one reason, and it's just because I want to extract a dynamic version for rtpengine, and I used git describe. But apart from that, it wouldn't be necessary to have Git in the base image. So the following practical thing will be having an infrastructure with 3 containers, one running Kamailio, and the other 2 running a web server and one zip-p, basically, and do some automatic tests. Just very quickly, though, in the last year, we've been using heavily the CI server, not just for doing the builds, which is sort of the initial, the common scenario, but also to do deployments. We deploy on every environment, so mostly on dev, but also on staging, and eventually also on production. Some of the deployments are only for test purposes, but others are, in fact, to provide the service. One combination that we found very easy to work with, but at the same time powerful enough, is a combination of Jenkins, Fabric, and Puppet. Fabric has a role that sort of replaces the Puppet master, because we use Puppet in a standalone fashion. So basically, we have a container with all the Fabric binaries and configuration. So we isolate it with all the SSH keys to connect to the target hosts. And then what Jenkins does is creates a slave, runs the slave runs Fabric, and Fabric transfers the Puppet manifests taken from Git to the target host, runs Puppet apply, and basically does the configuration management, does the deployment, and then cleans up everything. As basically Fabric and Puppet do something similar to what Ansible does directly. So connecting remotely via SSH, doing the deployment, and cleaning up. In fact, one example of this very recent is a brand new Puppet module which we did for Homer, which installs all the Homer components. And the relevant thing here is that, of course, one of the components is Kamailio. So you can see an example of deploying and running Kamailio directly from a Puppet module. The infrastructure, I mean, the diagram of the CI infrastructure is similar. I think I've just added a few things like, of course, the target hosts in the different environments, dev, staging, pre-production, whatever you want to call them. And of some additional things like reporting. We have a versions dashboard that tells us at each moment what version of Kamailio and its configuration is running on each machine on each environment. And of course, real-time notifications that could be email or Slack. So of course, you can do, if you imagine doing building and deployment, you can do automatic testing from CI. And in particular, for what concerns component and integration, I would like to put it all together and see a case study, which is something we needed for testing this new module, which is basically an HTTP client for Kamailio, which has the peculiarity of being asynchronous. So you can run a query and then asynchronously have a callback when the query gets a response. So the objective of this case study was to Dockerize all the components. So the three components, the system under test, Kamailio, a web server, and the container running the CP scenarios. So this is very simple architecture with three containers, one for CP, one for Kamailio, and one for Nginx. Of course, for Kamailio, we had different distributions, so we could test slightly different behaviors, in particular for TLS connections. And the yellow blocks are basically the volumes that we use in order to avoid rebuilding the containers every time by sharing what changes often, like the test scenarios or even the website, I mean the HTTP responses inside the containers. And then with a simple shell script, we prepare Kamailio, we build it at the Git reference that we want, we deploy it inside a container, and then we launch the tests. To do this, and it's the other tool that I wanted to discuss with you and share with you is the Docker Compose, which is basically a tool that provides a higher level of abstraction in respect to Docker when you have an architecture with more than one container. So basically, each container is seen as a service, and there is a very simple YAML file syntax to define each service, and define each service from what container is represented, what type of base image is needed, what are the volumes, the ports exposed, and the commands to be run. The very useful thing is that when you use Docker Compose, you don't need to know the IP address of the containers because it has an internal naming system. so you can address the services by name and not by IP address. So, for example, this is the compose file for the system under test. There is one image for Nginx, one for Kamailio, and one for CPP. The Nginx image exposes port 443 and has a volume for the website and one for the SSL certificates. While the CPP is very simple, just gets the SIP scenarios from the host via volume, and it doesn't expose any port. And the Kamailio, the system under test container, has got just a volume for the scripts, just to be able to run Kamailio. Exposes just port 5060 for the sake of this example, and it's supposed to run a shell script run.sh when starting. For free, we get environment variables inside the YAML for Docker Compose. So in this case, I'm just using 3 for define the user, the image, and the distribution. So I can inject this variable from the shell script inside Docker Compose and then just run, basically. Tell Docker Compose to run the system. So this is perhaps a little bit small, but this is the small Kamailio.cfg for the system under test, which I can show you perhaps in a better way. Like this. There you go. So it's a minimalistic Kamailio.cfg where we want to test the HTTP async client. So we set up a few parameters related to it. And then in the request route, what we do is basically we get a SIP message. We extract the target of the HTTP request from one header of the SIP message. This is just, a trick in order to trigger an HTTP request from inside Kamailio. And then you can see HTTP async query. We extract the URL from a header of the SIP message, and then we define a callback, which is the route, the HTTP reply route. So without blocking, we wait for the, we can do something else afterwards, but then without blocking, we wait for a callback from the HTTP async client. And when we get it, we go inside the HTTP reply route. If there is a positive reply, then we can build a body to be sent inside the 200 OK to CPP. If not, we send a 500. We send a 500 back. So for doing this, I just prepared 3 images, the 3 base images. We can be prepared at any moment. What we do practically is that we have one Jenkins job per base image. So every time there is a change in the base image, we just rerun the Jenkins job, builds the base image, and puts it in the private Docker registry. So we don't have to rebuild them every time we have to do the full Monty. And then there are just 2, for the sake of this example, there are 2 shell scripts. One is prepare build Kamailio, and the other is launch tests. So prepare build Kamailio gets a username, a base distribution, a path for the source code, and a Git reference for Kamailio, in this case 4.4. Launch tests is based on top of it, and it basically runs Docker Compose from that specific image, which is created on the first step. And then we can see with Docker logs -f what's happening on the container that it's under test. So this is the other practical part, and I wanted to so just This is the prepare build Kamailio script. What it does is basically just ensure that we check out the Git reference that we want for Kamailio given a source path. And we define a version with git describe. Then we assign a name to the container that will be the output of the build. And then simply we do a Docker run with a name for the final artifact, passing the source code, passing the volumes with the script, and the build script. Afterwards, what we do is we commit the container, and basically we create a Docker image from a running container, so that we can reuse it later in the launch tests script, which just gets the image to be tested, which identifies a distribution and a Git reference for Kamailio, and the target distribution. And then you can see here what it does is passing, after it set the environment variables that we saw, it just passes everything to Docker Compose and asks it to stop the containers that are, if they are running, and then rerun everything. After the Kamailio container is up and running, then it will exec the zip-p test scenario inside the zip-p container. Of course, all this is easy to automate and to put inside a Jenkins job. But what I wanted to do is just having it handy for now as manual commands, in case you want to try it out, even right now or even later if you want to discuss about it. So to run the full Monty, I think I'm going to run the prepare. I'm going to run the prepare script, which will check out Kamailio at tag 4.4 in the folder, and we'll do the build. Okay, so this is probably going to take some time. And after this has finished, we are going to run the 3 containers and run the tests and see the full scenario. So the main purpose of showing this in a sort of working fashion is just basically to get your feedback, to see if there's anything you see in a completely different way. Anyway, start a discussion by sharing what we've been doing already for some time, and also created some sort of excitement in the team, and some save in the time spent on these type of topics, and quicker tests for sure. And also, it made it simple to move, for example, from one distribution to another, which is easy to imagine, but also whilst doing upgrades inside the same distribution, or even experimenting with a specific version for a library. Having the ability of isolating completely 2 different scenarios, even if they are only slightly different, inside 2 containers was a clear positive advantage. So it's still building. Meanwhile, while it's building, you can either ask questions if you want, or I can show you some more static stuff with the slides.
Docker Compose does make another Docker, or it's...
Okay, so the question is what Docker Compose does. So basically, Docker Compose abstract the building or running containers. So for each service, which is inside, basically defines a container, you have two options. One is to specify a folder for the build. In this case, Compose will trigger the build of the image and will run it. Or you can specify an image name. In that case, it will just run the container using the image, either from local, if it's existing, or if it doesn't exist, it will try to get it from public. But in fact, it provides an abstraction for running containers, but also for the IP addressing, because as I mentioned, rather than having to address each container with the IP address that it's dynamically created by Docker, Compose associate a name. So I'll show you that zip-p will address the Kamailio by the name of the container, not by the IP address. That anyway can be seen, and it could be retrieved with, there is Docker inspect, provides all the information, but it's less handy. So the build has finished, and the image has been committed. I mean, the container has been built, has been committed into an image, and you can see that the name contains the distribution, Debian, and then the output of git describe. So it tells us that it's using 2 commits after tag 441, and in particular the git, there is also the initial git SHA. So you can pinpoint a specific git reference. After that, you can just basically use that image name, and with launch tests, you can address the tests specifically to that image. And yes, so in this case, Docker Compose will run all the 3 containers. For Kamailio, it will use the one that you just specified, so pinpointing a git reference. And then once the Kamailio container is running, a script triggers zip-p and runs the test suite. In this case, there is one scenario, but it's obviously easy to imagine a full test suite. As it happens already for the main Kamailio project, but in this case, it's an example of simulating the entire infrastructure in your private architecture.
So if you have questions, I have the microphone. Make a sign so it's better sound around.
And for example, I can show you very quickly. These are the 3 containers that are running. You can see them with Docker PS. You can see what image they use, and the names are associated dynamically by Compose at runtime. And basically, it's the project name _ service name _ a number.
How do you know when you can start your testing?
So how do you know how you can start your testing? Basically, what Docker says is, I cannot care about your application in the container. I can give you a feedback when the container is up. But in this case, as in others, the container up doesn't mean that the application is ready. So what they recommend is basically you have to do your own tests. So you can do, telnet, a zip probe. You can
just do waiting for POP to be your own application.
Yes, this is what I did. And sorry.
I was just wondering, do you have a collection of scripts available somewhere as a form of a Kamailio test suite?
No, I don't. The objective is, since we started this work, is to generalize the work we are doing and then share it. The main purpose was testing the HTTP async client. So this is the custom need, but it's something we would like to do. Yes. Just very quickly, just to show. So if you look inside the shell script, just to run the scenario, you can see what I mentioned, that Kamailio async is in fact the name of the service, and this allows you not to know the IP address of the container. So it can be generalized also because different installations of Docker can have a different virtual network to use. So it's not easy. It's not always obvious what addressing a container is using. You could use something like Docker inspect, which provides a bunch of information around a container. It's a lot of stuff that I mean, all the information available, it's provided here. You can perhaps filter it a little bit, and you can filter the IP address, and you can get the IP address associated to that container. So you can do that, or with Docker Compose, which was one of the things I wanted to share. You just use the service name.
How does the container know about names? Is it just an etc hosts entry, or how is this managed?
Right. I don't know. I don't know the internals of Docker Compose.
Sorry, I know the answer.
I can tell you. Everyone is answering here.
So actually, it passes in an environment variable.
No. When you associate a link inside Docker, what it does is adds an entry in the etc host.
Cool. So Docker adds an entry in etc hosts. Okay, cool.
Question there.
How large and complex is your Jenkins configuration?
A lot. And it's...
What was that?
A lot.
Have you thought about using Jenkins Job Builder to define that outside of Jenkins?
No.
You may want to look into that project. It's another OpenStack derived project, but one of the nice things about that is that you define all of your jobs as code, which then also allows other people to contribute and fix things, and basically makes Jenkins very stupid. We started using that on the Asterisk project about 1.5 years ago, and we've actually even had a couple of community members contribute some things back. So just something to also look into.
Job Builder for Jenkins?
Yeah, it's called Jenkins Job Builder. It's Python and YAML, essentially. Okay. So,
thanks. What we do is once we have the Jenkins jobs, typically they are very similar one to each other, even if we try to abstract them. What we do is, since we are managing Jenkins with Puppet, basically the XML that forms the job is all in Git. So, but yes, we'll check that out.
Did I understand you correctly? You export Docker images and use in production then afterwards?
No, this is...
is this a pure test environment, or
yes.
How do you...
Yes, so for now, what we are using to actually provide a service related to Docker and Kamailio is Omer. But of course, it's not user-facing. I think it's going to become the future, but at the moment we are still not using Docker on production with Kamailio inside to provide the service. We basically use it to generate the artifacts, then we do the deployment. Yes, in fact, this was probably one of the points for the conclusion. I think it's going to come. I mean, the services are going to, sooner or later, are going to be delivered inside the containers. So the containers not just used as a useful tool, as I've been describing. But to do this, we will need a proper service discovery, so that basically we can delegate where to run the containers for the services and where the services are available. And that's pretty much. Sorry?
Have you looked into any of these tools?
Can you?
Have you looked into any of the service discovery?
The service discovery. It's something that I'm trying to, yes, in fact, there is one thing in the references. There is the last one, Docker networking and service discovery, which there is a plethora of tools. To be honest, it's something that I'm still looking. I found that one quite interesting. There are some names that are more common than others, but it's, just the last few seconds to thank Federico, Camille, and Victor, because, I mean, Federico and Camille just did all, apart from being the authors of HTTP async client, they did a lot of review for the testing system because they use it. And Victor, for everything is done publicly, which is a huge amount of work in this area.
Your name?
Sorry, say again?
Okay. It's okay. It was a typo with the name, but it's no problem.
Sorry.
It just needs to change the name now. It's not a big deal.
What?
Okay.
I'm going to check. Okay, that's unless there are other questions.
Questions, Docker, continuous integration. And of course, now, after the framework will be available, it's your turn to push scenarios for testing and so on.
Observe any performance-related issues? Sorry. Did you observe any performance-related issues when running a Dockerized version of the Kamailio?
Well, it's hard to tell. In theory, it should use the resources available on the machine as if it was a user space process. But since we don't run it on production for Kamailio, it's hard to tell. In my opinion, it's absolutely feasible. Also, I prefer to consider scaling horizontally, so not having instances too loaded, but scaling in that way. So again, but I don't have numbers.
Okay, then thank you very much,
Thanks.
Giacomo, always.